All right. Welcome back to the channel, the live stream on Twitch. I thank everybody for watching, checking us out. I really appreciate it. Subscriptions are growing, and that's pretty cool to me. Even though it's a small number, it's still pretty impressive that the information and the videos I'm doing are reaching out to somebody. And that's pretty cool. So I really appreciate that. Again, don't hesitate to leave comments, ask questions. I will do my best to answer them, respond to them. Just be respectful, constructive criticism. There's no reason not to be. Be respectful and professional with others around you. That's all I'm asking. Other than that, any questions, fair game. If I miss something, if something's not clear enough, I'm always happy to explain. If you're watching the Twitch stream, don't hesitate to jump in the chat. I will do everything I can to answer and relay the questions and the answers on the video. But definitely like and subscribe. Hit that bell notification for to be informed when we get new videos posted to YouTube. I was going to just do it once a week, but I feel like I want to get this video series out there. So I'm trying to punch them out as often as I can. So without further ado, let's pick up where we left yesterday. We were working on some of the SOPs because right now, without parts, I can't do anything else other than catch up on paperwork, and this is important. We're writing procedures, work instructions, and getting some documentation, getting some things put into place so we can properly document and log and record things. So we have our incoming inspection. So it's pretty clear, consistent. We'll clean it out. So we have the non-conforming log that we finished yesterday. So let's just kind of recent documents and coming NCM log. Let's double check it. All right. Disposition. Okay. Perfect. NCM number. Okay. So everything's looking fine there. Now, as far as the non-conforming materials number, we never actually officially kind of documented how to arrive at that. All right, non-conforming materials. So that's that. Let's see. Well, we're going to kind of change this position. I'm going to kind of all NCM and okay. That way we keep it consistent. Everything, even if it's, accepted, we want to log that we accepted it. Now we want to put in here NCM number. Use the month, year. Yeah. Let's see here. Current month, year. And we just do year for the last two digits. dash XX, where is the sequence the November 15th, 2025, and is the so yes, do your best to not only explain what you're trying to accomplish, but also give an example. It spells it out for the person doing the job, and it makes sure that it gets done that way every time, or it does its best to make sure things get done that way every time. We're only human. People make mistakes. But if the quality manager is actually auditing the file or having to go into the file to forgot to get out of Steam, you're going to see my pop-up notifications of my friends. But hey, it's cool. The quality manager, or you in this case, since if it's a one-man team, would be auditing that every time they're informed anyway, and they could just let anybody know if they're not doing it right. The key is to be as consistent as possible in the long run. Let's go. Okay. So we have the method how to generate the NCM number, and so let's also here. Dang it! I clicked on the spot. Okay. NCM number follows the unit that out. Now, one of the things we should do is possibly even a QA of approval, like a deviation allowance form. Maybe not just a log, but maybe it could just be a log. Maybe we can do that. So let's see here. NCM. Okay. We'll figure that out. Maybe you could just have a form. On QA approval, for now, a note must remain with the approved inventory, indicating the date, the CM number, who it's approved by, so we can have it just simply like that for now. It's something we can update later if we want to. Let's just go and do it. Something just like a little note. It could be just handwritten. And since it'll have the NCM number, It could be referred to in the log, which would be here. There's nothing wrong with, highlighting rows every other row. That makes it easier, filling in different colors. I've seen things done like that, alternate, like, white, like a light blue or something. If you want to break that up, make it easier. This will, you could do the log however you want to make sense to you. But since this will be the record and we're going to record the disposition, so a note right now is all you need, and it stays with the inventory until final is consumed. Let's put that somewhere. There we go. All right, that makes more sense. Again, we're spelling things out. It removes the error factor, helps control the human factor in this, and it also reduces any arguments, any conflicts of interest, or conflicts of interest, or interpersonal conflicts. So I don't know what I'm supposed to be doing. It's spelled right here. This is how you do it. Again, it's hard to argue. It's hard to argue against when you're trained on this stuff. When new employees come in and they're trained, and you do any additional like retraining, refreshing, or anything like that during, through audits and stuff. So one of the things I've been asked outside of, these streams and videos in my years, working, with other companies. Some people, people have asked me, like, why even bother starting this stuff? Why try to follow a QMS system, or, even try to do ISO right off the bat? And I don't know if I've explained this in another video, but not only does it make sense, but it's much easier when you're building it into your company at first. For one thing, if you're one person or a small team doing this, you're already all on board with it. So you don't have to worry about getting buy-in when the company's like 30, 40, 50 years old. At that point, you got to get buy-in from management. You got to get buy-in from stakeholders. And it gets costlier and more difficult to do for an established company because they've already got processes. Again, if it's not documented, they've already got processes. It's much easier just to start this off the bat. You're building your business with, steel beams, steel framing rather than, wood framing. That's basically the way I see it. You start a business, you're basically building a house with or a business building with wood framing. Yeah, it's good, but it's much harder to replace that wood 30 years later with steel if you want to, solidify your foundations. It's just much easier to do it from the get-go. Even if it's messy, you still have a system in place. And it's just easier to train on when you have employees coming in. Because even though, you would, during hiring, you would, let company employees know, oh, hey, we're transitioning ISO. You still get pushback. You will still get pushback. I've personally dealt with it at other companies. When we were, especially the one where we're becoming AS 9100 certified, existing employees push back. They don't want to do it. And that happens. So this, starting your ideas and everything from this at the get-go is helpful. So we've got that, we've got the MCM, kind of clarified that. So I think this is good. Then again, the note can be anything handwritten, just something thrown together in Word or Notepad and printed out. But just physical note. There we go. Keep it with the approved inventory, indicating all this until you've used up the last of that product. Perhaps we could also say approved materials. What we could do is should take first in, first out. So basically try to consume those materials first just to get them out of the way. So that's what I would suggest. So if you're approving a deviation, just go and throw them in production, get them out. Unless there's, you know, where possible. There we go. Clarification. Sometimes you can't do that. Sometimes there's just no choice. So we have that. Okay, so enough of this. So since we'll be building boards, and we want to kind of get some things rolling on that. All right, we're going to pull in don't need the project outputs. All right, first figure out, is it in here? Project documents. Yes, traceability matrix. So let it detect. It seemed to do pretty good there. Yeah, you could keep it in CSV, but honestly, again, I don't like, it just makes it too difficult. I like working with spreadsheets like this because it's nice, organized. Okay, so we're going to look at the traceability matrix. We're going to file, we're going to save it as, put it as XLSX. All right, no. No. Project documents. Okay, make sure that we can get in there. Now, let's just go and get rid of the CSV file. Don't need it. I don't prefer to use that way. So let's close this out. That way we don't have to fight that. All right. So this traceability matrix was built off of the requirements document. No, PRD. So that is functional requirements. So that is basically a matrix that basically pulls from the PRD and grabs the headers, and then it locks it together with the test ID. So again, Copilot help write this. These are functional, let's see, FR functional requirements. So performance requirements, safety and regulatory. So these are them. And then, so basically what this is, it ties the requirement that we outlaid to the test, either the test process with its supporting documentation. And mindful, this is, some of this could be destructive testing on the first board, depending, because we will want to basically, I don't see their test here. Okay, we've got test points, LEDs or visual indicators, and we have a couple. We're going to clean all this up. Do we have... Okay, yeah, we can check out that. I don't know if we're going to do OTA. Don't know. We might be able to it. Might not worry about this thermal protection reverse. Okay, so like this, reverse polarity protection. When we get to that test and all that. Now, we could actually create one document outlining all the tests, and I think that's what we'll do. Basically, the test process document that outlays all these as separate sections, and then the same thing for the test log. It'll be, it'll just cover, a block for, did it pass, did it fail? Because the reverse voltage test could actually destroy the diode or damage the board. Thermal protection. Any of this could damage the board. EMC pre-cert test readiness. That I don't know if I have the equipment to do, but I'll look into it. We'll see what we can do. So yes. Okay, so our functional requirements. So this is going to be interesting. So what I'm going to do is to make life a little easier on me is I'm going to drag this off the screen and put on my second monitor. So I can close a preview. It's annoying right now. Okay. Make it easier for me to go through here and clean this up. Requirement ID. Dash 004. All right. Yeah. Okay. Design description. Okay, implementation ID. Okay. All right. Pluggable headers for RS-485, stepper signals, and GPIO. Not really doing all of that. We do have RS-45 motor outputs. I mean, technically we do for the GPIO. Control inputs. Huh, interesting. All right, design description. Test ID. Yeah, so Copilot helped write this, so it's a little bit confusing where its thinking was. Let me see if I can go back to what it was thinking. Because I think it started writing it. Let me see here. All right. Okay. Are we here? All right. All right. This is going to be a pain in the butt because of the way it wants me to write some of this stuff. So some of these aren't even really tests. So these are functional requirements. So ESP firmware. Okay, so requirement is ESP32. Implementation description. So little headers. Weird that it. Okay, formatting's getting weird on this. All right, 004. Go back to code. Yeah, we'll clean all this up. I don't think I'm gonna do. Not sure about BLE provisioning and OTA firmware for this. I don't know yet. All right, these are functional requirements. We're just trying to point to make sure that we do meet these requirements. So trying to see which one of these functional requirement. 5. Oops. All right. 5. Or bridge. Helps if I can spell today. They could just be brief tests. That's why I'm just going to combine everything together into one document, one test log. Yeah. I don't like the spelling of that word. Here we go. Design description. Points. Implementation. Did I 2, 3? Boy, I really did good there, didn't I? Like, wait a minute, why don't things match here? There we go. Things are PCB points. Some of this does not make sense at all the way it's written. This we'll have to think about this. Test points exist and are indicated properly. Geez, my goodness, I can't spell anything today. All right, test points, that's a good one. Functional requirement. LED. LED. Function. LED. Function. I think we'll be able to make more sense of this once we actually start writing some of the other things. So and instead of now we could write the actual test document, the actual test plan, basically in Markdown. But I prefer to keep the log file as an Excel file like this, just an Excel file like this. It just makes life a little bit easier, especially to organize thoughts and headers and sections and stuff. So let's stop with this and let's kind of take what we have here and digest it. So what we need to do is basically design a, again, Copilot help me write this. This will all change, all be cleaned up. We'll make everything match. So like we got kind of pulled that out. Pulled that out. It's not really functional requirement. 5, 6, 7. Is that where we are? We got 7. Yes, sir. All right. Okay. Flappable headers 4. Motor outputs and control inputs. Technically, control inputs are GPIO, but we're just gonna. All right, kind of keep that. All right, bump, 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 bump. So what we're going to need to do then is technically that's, while it's kind of QMS related, it's not a direct QMS document, is the actual test plan for this. So it's not going to go here, not here, but it's going to go on the project documents. Do I have a test plan? I got a couple of test documents, but I'm not liking those. We're going to kind of steal some of the headers like this. So things kind of match, but we're not going to have Copilot write it. Logs, okay. We'll get rid of CSV files here too. You know what? Let's just get rid of that. So we're going to create a new file. P101 220 2501 dash test plan. All right, that's what we'll do. Kind of close this, get out of the way. What we're gonna do is we're gonna kind of copy this product. Or give a date. We're not going to really ISO clause reference. All right. Scope. We will kind of put that in there. Define. Find the elements to all right. Okay. It applies to the ESP32 based DRV 25 All right. So that's the scope. That way we can make sure there's a constraint on this document. That way nobody accidentally tries to extend it to any other products. It is just for this. All right, so it's our project ID, document ID. Let's get that renamed. Test plan. All right, so let's look at. So what we need to do then is kind of come down here. Okay. Functional, yeah. FR, functional requirements. So here's where we'll take from our spreadsheet. Again, I'm dragging that out. FR 001. Does this have to be like this? All right. I do want to preview this, kind of get an idea of that FR001. So that's the functional requirement there. Okay, the design ID. Okay, so maybe what we can do is we come up here. Okay, 2, 3. Required materials. There we go. So here's what we can do. Required materials. So the first thing we should have is the test log for this. So let's open up our spreadsheet. We're going to create a file. We're going to create a new spreadsheet, blank document. And we're just going to go and save as. So let's go here to projects, stepper controller, project documents, test logs. Again, we're going to change this to this. We're going to call it P. Okay, -01 for revision 1. Test plan log. So we have that there. Code, it's going to be here in test log. So I'm just going to rename it so I can just copy. It's kind of located in the ones. To store the there. Okay, so it's one of the required materials. Definitely want to outline all of this. Loads of fun. So let's see here. Fully assembled device for testing that for testing. So this test plan, we might change the wording a little bit, but we're going to consider this something like a first article. And it might be more in depth. We might have to run through the test plan a couple more times, or, you know, multiple devices to run through this testing. We'll have to figure that out as we go. So this would be like your first product, your first article inspection test, which would be different from like a production test. So the first article, this production test, or this test right here, is basically a validation that you followed everything, that everything works as you spec'd. Everything looks good and it functions as you specified, and you're happy with it. Then you would have a production test and associated log files for when you would go to actually put this product in the market, which would be a lot simpler. It would be basically just, you know, like a quick visual inspection, hook things up, does it smoke, You know, does it power it properly? Do you get the proper voltages? Can you program it? Quick control tests or whatever. You know, you can, you know, have so for me, for making this product, I would have like I would put it together a test fixture with basically a power supply or power supply connection, so I can hook like an external benchtop supply to it with like maybe a couple buttons permanently mounted to it, and a stepper motor I can tie all into the pluggables and power it up, program it. You know, I'd have the access to the computer so I can flash the firmware to the ESP32. It'd be like a generic as shipped firmware that just does a few things. You know, it's very basic, like limit switches. Basically the motor rotates, you know, clockwise until you hit the one limit switch, counterclockwise as you hit the other limit switch, basically, and maybe like a button to start and stop it, basically to test your limit switch inputs and your control inputs. We can test all, you know, all three of them and have it do a few different things for that test, and just be firmware that's on the device, ready to go. Just kind of like it as example code. It'd be like example code. We can also test the RS-485, the FTDI interface. So just basically it'll be a quick test for production, just to make sure the units that we're packing out the door are good. But this one is going to be more in depth. This is where we're going to check thermal properties. We're going to make sure, you know, everything, you know, the board, we're going to stress test this thing. So we're going to push it to its limits. The only sadness I have is I don't have a thermal chamber. I mean, I have a toaster oven I can use for heat, for simulate a heated environment to see how it performs. But I don't, you know, I could take it to my kitchen freezer and test it in a cold environment, but it's not pleasant. So one of my last jobs, we had a thermal chamber that could, you know, do heat and cold that we would test devices in. It's a huge thermal chamber. You can fit, you know, I used it for all kinds of things, for curing epoxies and stuff and doing testing and things like that. We could run tests on multiple boards simultaneously to test their capabilities for things like this. So I'll do the best I can for what I have. We could always use the heat gun and kind of heat it up to see how it performs, kind of, you know, with thermocouples and stuff. So one of these units I may be permanently attaching thermocouples to for the testing to get multiple different readings, different, you know, temperature variables to see if to validate the temperature sensor, and to also make sure that I've kind of got it reading right. I've got an infrared temperature sensor, non-contact, so a couple of different tests. That's what we'll be doing. We'll be, you know, pushing the voltage up, see if it fails, where it fails. Like I said, we're probably going to destroy at least one board, maybe two, during some of this testing, just to see what the limits are. See if we push the voltage up to 30 volts. Do we fry anything? Will the board still work? So that's what we're going to do. So required materials, fully assembled device for testing. So we want to make sure we outline all the stuff you need for the testing. And that's what we're trying to do. So we're going to need a supply of limiting, because we'll want to, there's part of the testing is you want to current limit your power supply at first, give it very low current. You're less likely to fry anything that you might be able to rework and fix, like maybe you made an assembly mistake, like put something on backwards. You could fix it without frying the board. Really depends, because an ESP32 without firmware, like you buy the dev kits, the ESP32 dev kits are already assembled, have the USB port on them. They typically ship with firmware, like to light the LED and stuff like that. Just, but when you buy just the SOMs, there's nothing on them. They're empty. I think they just have the bootloader and that's it. And you just flash your firmware. So they'll just sit there and do nothing, and without inputs firing off, these boards should pull very low current. So that's what we're going to look at. You know, we're going to look at, you know, their idle current. We're going to kind of see what they do.
create some typical cases, just see how they perform. But we'll get there. So benchtop power supply capable of current limiting with the ability to deliver. Yeah. Deliver up to 30 volt at 5 amps. I think my power supply can handle 5 amps. I have to double check. But it should be able to deliver it. Because current is basically sourced. So you have to be able to deliver the current that the device is going to be able to use. So if your benchtop power supply can't deliver the current, because one of the things we might do is actually try directly shorting out the motor controllers, the motor outputs, to see what they do. From the data sheet on the motor controller, the stepper driver, it's supposed to be able to handle that and indicate a fault. So we're going to have to definitely write some test firmware and do a whole bunch of different stuff. It's going to be lots of fun because I am not a super coder. I'm learning on my own. I don't do coding for a living. I don't do firmware development for a living. When I got into electronics back in the day, everything was through hole. We didn't have the huge influx, the huge use of microcontrollers and ESP32. Nobody knew what any of this was. So doing embedded firmware wasn't really a thing. Everything was pretty much analog. And you pretty much had to have a doctorate degree to do any of the computer programming to do anything. Things were put together in assembly to program the microcontrollers back in the day, for the ones that did exist. Nowadays you can, even though it's like $6-10 for an ESP32, that's still cheap for the power that they have. And then if you want to get into things like PICs, you're talking $1 for a PIC 18F, which can do all kinds of cool things for a small size and for around $1 a unit, and it's crazy. You just look at like a smartwatch or your smartphone for those who grew up with this technology, it's taken for granted. But for somebody who grew up through the development and the rise of this technology, just watching the world explode in this technology, it's mind-boggling. It's like kind of overwhelming. I look at it with awe. So does that want like a dash there? That's fine. Okay, so you want a benchtop power supply that can do that. That way you can at least push the power to the unit. We want a multimeter. I think those are of resistance. Yeah, typing is not my resistance. And temperature reading. So yeah, I've got a little handheld DMM that has that. It can even do capacitance, I think, but I'm not really caring about that because we may need to do things like this. The power supply I have, the benchtop, does have a real-time current, but I'll want to validate, make sure they match using a multimeter. Let's see here. Infrared. Spelled that wrong. Infrared temperature gauge. And so I have Kapton tape, which should work for holding thermocouples down, but we can also, I could also use epoxy. They make a really good epoxy for this purpose and just permanently bind the thermocouples. I'll test. The Kapton tape should work just fine for this to hold them down for testing, because we'll define a couple of points on the board. We could reference the KiCad and kind of, I might be able to pull an image out and like a render of the board, and we can have a photo, graphic to kind of go by. So we'll figure that out, how to do that. So thermocouples and materials to affix them to the PCB. Other required materials. Yes. Basic hand tools such as screwdrivers. Yes, you definitely want to outline that. Again, it removes the question, and that way, you can kind of use this as a pick list. Like, say I'm going to be testing, doing this test today. These are the things that I need to use. I mean, I need to grab and set up at my bench. But most workbenches will have this, but it's still best to outline this. So let's see, what are the requirements, basic materials, that we think we should need. We can always think on that later. So now let's start here with yes. Initial testing. So now these aren't even technically the functional requirements. This is like initial testing. So we want to define some things that we need to do first before we do anything else to the board. So the first thing we should do is, let's see, that's how this looks. Visual testing. Is that the more? Okay. Visual inspection. So for any workmanship defects, such as poor soldering or off pad components, is following IPC class 2 criteria. So you just want to kind of look for, to make sure it would be compliant with IPC class 2 criteria for electronic assemblies. So you would visually inspect, store the test plan log in the file. So here's where we would come here. So let's kind of keep that out of the way. Don't really need that this minute because we're going to be running on time and I don't want to drag this out. Because again, this is going to be a long process. I might be making these videos for quite a while. Because this takes time to develop all this stuff. And if you want to do it right, take the time. So what we can do here is, let's just start down here. We're going to, right now, not do much. Actually, what I might do is kind of, we're going to that. Let's see. Initial testing. Let's see here. Test item. Description. So I like doing this better. Test item. Itself. Description. I hate when I do that. Result and notes. Word cells. All right. So let's go and do that. Result. Notes. Okay. Cells. Result would be like pass fail. Cells. So let's just go and drag this down. Oh, that's going to be the header for this section. All right, so I have to unmerge and merge. So what we can do is kind of give that like a little fill. And let's go a little later fill. One thing, it helps break it, so each test item will each section will have its own format cells. Let's get these borders. Okay. So in this, we can even kind of use as a template for other tests down the road. But for now, we'll just suss it all out here, and if we want to make it a template, we can always copy it, give it a generic name, delete all the stuff that's in it. Test item. Visual inspection. The solder joints is actually, let's make this even simpler. Ship for IPC class 2. Result would be pass or fail. If it's fail, you would put a note in there. So, visual inspection. Note. Any fail condition. We might want to globalize this. Let's see, for any test So we kind of want to clarify. We can change that later. But why continue going through a test process if you've already got a failure? There's no reason for it. So if you, let's say you had a larger company and you had separate, like an SMT line, an assembly area,
and they were handling building even the prototype batch. And then they got to whoever was doing the testing, whatever engineering tech was responsible for this part of the task. If they can't even get to this point with a failure, even let's say it fails even visual inspection, the very first thing you're supposed to do to the board, that means you got a failure somewhere along the lines. That means your process is out of control. It needs to be addressed. So we will basically stop testing and investigate the issue. And note any resolutions. There we go. And then you can continue. So visual inspection, you want to visually inspect. Okay. Oh, so let's go here. Schematic and BOM for the device. So you definitely want the schematic on hand and the bill of materials. That might come in later. So visual inspection. Initial measurements. Enter in ohm and resistance mode. Check the so this is where we probably could use KiCad. And I'm gonna call it here because it's gonna take a lot more to jump into, to finish out some of this documentation. I'm gonna have to get KiCad open so we can look at the test points, refer to them, and then write this even better. I should have opened KiCad and had everything ready to go. So we'll call this here because again we're an hour in. And I just want to kind of keep these videos a little shorter, easier to digest. It's just another prime example of how much work actually goes into doing this stuff right. And I think a lot of social media makes it look easy. It can be easy. It gets easier over time, but it takes a lot of effort to get it to that stage where it's easy. That's why I wanted to do this series, to highlight more of the truth. It's not something that you can easily jump in. You can jump into it if you want to just smack something together and just throw it on Etsy or eBay. But if you want to grow an organization that can become something like world class, could even become Fortune 500. There's nothing wrong with dreaming. There's nothing wrong with looking forward. And wanting to create an empire. It's that future thinking, that forward thinking is what grows companies. The ideas help, but you need the foundation behind it. You need the vision. You need the forward thinking. You don't just plan and do for tomorrow. You plan and you work towards a year from now, 5 years from now, 10 years from now. That's where your future lies. Today, tomorrow, they pass like water under a bridge. If you want to build up an ocean, it's going to take time. It's going to take a lot of water under that bridge every day to fill an ocean, and that's what we're looking towards. Is trying to build something bigger than just a small pond. We want to build an ocean. It's an ambitious goal, but I believe that's where success comes in from. Is when you have the ambition and you put the work behind that ambition to get there.
And this is unfortunately part of the work involved. But the great thing is once you get your first few done under your belt, the first few, once you get your SOPs written, okay? Once these are written, they're pretty much done because they're global. They're company wide. They're done. Once you get your first test plan written, you've got a foundation to build other ones off of. You can start copying and pasting and just editing it for what you need. Once you get your test logs, again, you can use it as templates and copy and paste. It gets easier. Your first one's always a pain. Your first success is great. Your first failures are always the worst, especially when you've spent money on things. So I just want to, again, I'm not encouraging anybody to spend money that they don't have. I know times are tight. If you've been following along, you definitely saw how the tariffs and just the increase in prices have just made me wince. It's just, yeah, things are a little tough, but I'm not going to give up because they are, because things can get better on the other side. Next year, middle and next year, things could get better. Who knows? The situation could change. So I'm not going to give up just because things are a little tight right now. I'm just going to be a little more careful with what I do. While I don't like the idea of having to destroy a board for testing, it's necessary. Unfortunately, it's a necessary process. If a board gets damaged or a couple boards get destroyed because I had to do some destructive testing, that's the name of the game. I want to make sure I catch a problem before it becomes a problem for a customer, before it causes an issue in the field and somebody gets hurt. Now, why you can't account for or test all edge cases, because there are things that I've seen people do with their products, and you're like, okay, how can I know that you're going to do that with it? How could I have known? That's a you problem. I could never have thought to test for that. And I've seen things like that before. So prime example. Don't know if I've talked about this before, but the one company that I worked with, so we made this product for automation control. And the original product that was first developed had a mixture of people developing the firmware for it. And they had accidentally left some debugging code in there that would generate flags that would send along, I think it was DeviceNet, either DeviceNet or Modbus, but it doesn't really matter. But so these flags would get sent along in the data. And one particular customer thought that was a feature, an undocumented feature. And they actually built a process around those flags, even though they were debug flags used for testing. Nobody removed them from the code. So what happened was, so they built their process around it. So all these years later, the one microcontroller it was based off of went end of life. So everybody was left scrambling, well, given the time to have to report the firmware to another microcontroller. During the porting over to the new microcontroller, this debug code was located and removed because it was unnecessary. It was for debugging only. It was actually removed. So when the updated product got put on the market, the customers started complaining like they were not getting data that they had built their process around. So, and they were a pretty big customer. So one of the things we had to do was actually patch the firmware to put that debug code back into it and generate those flags again. So yeah, all kinds of weird things happen when your product hits the open market. You don't know what people are going to do, what they're going to take advantage of. You can only test and catch so much, but you want to do as much as you can now. Try to think through and catch, especially the closer edge cases. And that's why we're doing this. So, again, I'm going to call it here. I tend to go on these tangents. I'll get things cleaned up and pushed to the GitHub. So if you're following along downloading, you want to get the most current stuff, it'll be there probably within the next 20 minutes after I end the video. Thank you for watching, and thank you for hanging out with me. And the next video stream on Twitch should be Wednesday around 6.
We'll be picking up where we left off. Thanks. Have a nice rest of your day.